In this video, we are going to solve square root equations. You'll notice here at the top of the page, I have listed 4 steps for whenever you are solving square root equations. Step 1 is to isolate the square root. Now, if you have more than one square root, you need to have at least one of those square roots isolated to be able to solve. Step 2 is to raise both sides of the equation to the second power because the square undoes the square root, just like how division undoes multiplication. They're inverse operations. Step 3 is that we are going to simplify and solve. And step 4 is that we need to check for extraneous solutions. Because we're going to be raising both sides of the equation to the second power, that equation can give us answers that are solutions to that equation, but are not solutions to the original equation. So we always have to check our work whenever we are solving functions that include square roots. So let's go ahead and look at example 1. On example 1, it says solve each equation, then check for extraneous solutions. The first thing that we want to do is we want to isolate that square root, meaning I want to get this square root alone. Right now, the square root of x plus 1 is being multiplied by 2. To undo multiplication, I'll do division. And so we'll have the square root of x plus 1 is equal to 7. From here, I can undo the square root by squaring both sides. The square undoes the square root and leaves me with x plus 1. 7 squared is 49. To undo addition, I'll do subtraction and get x is equal to 48. So I have 48 as a solution. Now I need to check it to see if it is actually a solution or to see if it is extraneous. So we are going to plug into our original equation up here, and whenever I see an x, I'm just going to go ahead and replace that x with 48. And so I'll have 2 times the square root of 48 plus 1 is equal to 14. 48 plus 1 is 49. The principal square root of 49 is 7. 2 times 7 is 14. 14 does in fact equal 14. This is a true statement. And so 48 is in fact a solution. Let's go ahead and try that again on example 2. The first thing that we want to do is we want to isolate the square root. So I need to move the 4 to the other side. To undo addition, I'll do subtraction. So I'll have the square root of x minus 1 is equal to 1. Now that my square root is isolated, I can go ahead and raise each side to the second power. The square undoes the square root, and that leaves me with x minus 1. 1 squared is 1. To solve for x, I'm going to undo a subtraction by adding 1 to both sides, and I will get that x equals 2. From here, I want to go ahead and check the solution to see if it works. So I'm going to have 4 plus the square root of 2 minus 1 is equal to 5. 2 minus 1 is 1. The principal square root of 1 is 1. 4 plus 1 is 5. 5 equals 5. This is a true statement, so 2 is in fact a solution. On example 3, this is our first example where we have more than one square root in the problem. Remember that at least one of your square roots needs to be isolated. This square root is by itself on this side, so the square root of 35x is isolated. The square root of x plus 2 is not isolated because it is being multiplied by 5. That's okay because this one is already by itself. So, to undo the square root, we are going to square both sides. The square undoes the square root, and that's going to leave me with 35x. Over here, I have a product being raised to a power. So if you think back to your exponent properties, if you have a product being raised to a power, then each factor of that product needs to be raised to that power. So 5 raised to the second power is 25. The square root of x plus 2 raised to the second power is x plus 2. Notice how I kept x plus 2 inside the parentheses. This is because this whole thing was being squared, and this whole thing was being multiplied by 5. So x plus 2 is being multiplied by 25. From here, I'm going to go ahead and use a distributive property. And so I'll have 35x equals 25x plus 50. I want to get my x's on the same side of the equation. So I'm going to go ahead and subtract 25x on both sides. So that will give me 10x is equal to 50. Oops. Write that a little bit better. There we go. To undo multiplication, I'll do division and get that x is equal to 5. So let's go ahead and check to see if this is a solution or not. So I'm going to have the square root of 35 times 5 is equal to 5 times the square root of 5 plus 2. 35 times 5 is 175. 5 plus 2 is 7. I'm going to simplify the square root of 175 to see if it simplifies to 5 square root of 7. To do that, I'm just going to use prime factorization. The smallest prime number that goes into 175 is 5. It goes in 35 times. The smallest prime number that goes into 35 is 5. That goes in 7 times. And 7 goes into itself once. So here I have a pair of 5s that can leave the square root symbol. 7 doesn't have a pair, so 7 will stay inside. And so we'll see we get 5 square roots of 7 equals 5 square roots of 7. This is a true statement. And so our solution is in fact x equals 5. When we go to the next page, we're doing the same exact process. Your first question is to always ask, is my square root isolated? And in this example, it is. Because our square root is isolated, we can go ahead and square both sides. Our square undoes the square root, and that leaves me with x plus 18. Over here, I have a binomial that is being squared. So that means that I have x minus 2 times x minus 2. You can multiply these binomials using your favorite method, whether it's the area model, FOIL, distributive property, whichever method you prefer. I'm going to use a distributive property. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. So from here, you always want to combine like terms that you have on each side. There are no like terms on the left side of my equation. And on the right side of my equation, x squared does not have a like term. Negative 2x minus 2x is negative 4x. And positive 4 does not have a like term. From here, I notice that I have a quadratic equation. We've learned 4 different methods for solving quadratic equations. Whenever I'm solving problems like this, it's probably going to be the most feasible to either solve by factoring or solve by using the quadratic formula. You can use whichever method that you prefer. To solve using either method, I need one side of my equation to equal 0. So I'm going to go ahead and subtract x from both sides and 18 to get the left side of my equation to be 0. So I'll have x squared minus 5x minus 14. This is factorable. I'll have x minus 7 times x plus 2 as my factors. And from here, I can use the principle of zero products to solve. So I'll have x minus 7 equals 0 or x plus 2 equals 0. To solve this first equation, I'll add 7 to both sides and get x equals 7. For this equation, I'll subtract 2 on both sides and get x equals negative 2. So we have found 2 solutions, and we will need to check both of them to see if they both work. If one works and one doesn't, whichever one works is your solution, whichever one doesn't is extraneous. If both solutions do not work, meaning that you get a false statement for both, then you would have no solution. If they both work, meaning they get true statements for each check, then you would have both of those as your solutions. So let's see what happens. I'm going to start off by checking x equals 7. So when I check that, I'm going to have the square root of 7 plus 18 is equal to 7 minus 2. 7 plus 18 is 25. 7 minus 2 is 5. The principal square root of 25 is 5. 5 equals 5. That is a true statement. So 7 is a solution. Now let's check x equals negative 2. So when I plug in negative 2, I'll have negative 2 plus 18 is equal to negative 2 minus 2. Negative 2 plus 18 is 16. Negative 2 minus 2 is negative 4. The principal square root of 16 is 4. 4 does not equal negative 4. This is a false statement. So x equals negative 2 is an extraneous solution. So our only solution here is x equals 7. On example 5, the first thing that you want to do is you want to isolate your square root. So I'm going to need to go ahead and add x to both sides of my equation. When I do that, I get the square root of 2x plus 14 is equal to x plus 3. Now my square root is isolated, so I can go ahead and square both sides. The square undoes a square root, and that leaves me with 2x plus 14. Over here, x plus 3 squared means that I have x plus 3 times x plus 3. If I multiply that out, I'm going to get x squared plus 6x plus 9. Right now, I have a quadratic equation. So I want to get everything over to one side so that one side equals 0, and then I can choose how to solve from there. So I'm going to subtract 2x on both sides and subtract 14. So I'm going to have 0 is equal to x squared plus 4x minus 5. From here you could solve by factoring or by quadratic formula, whatever method you prefer. When I look at this, I can see that this is in fact factorable, and those factors will be x plus 5 times x minus 1. So I can use the principle of zero products and say x plus 5 equals 0 or x minus 1 equals 0. When I go to solve this, I'm going to subtract 5 on both sides and get x equals negative 5. For this one, I'll add 1 to both sides and get x equals 1. Excuse me. So from here, I have two equations or two solutions that I need to check. Let's start off by checking x equals negative 5. So when I do that, I'll have the square root of 2 times negative 5 plus 14 minus negative 5 equals 3. 2 times negative 5 is negative 10. A negative times a negative is a positive. Negative 10 plus 14 is 4. This principal square root of 4 is 2. 2 plus 5 is 7. 7 does not equal 3. So negative 5 is an extraneous solution. So now let's check x equals 1. So I'll have the square root of 2 times 1 plus 14 minus 1 equals 3. 2 times 1 is 2 minus 1 equals 3. 2 plus 14 is 16. The square root of 16 is 4. 4 minus 1 is 3. 3 equals 3. So 1 is in fact a solution. Let's go ahead and look at example 6. On example 6, we have two square roots, and we need at least one of them to be isolated to solve. This one over here is isolated, and so we can go ahead and square both sides. When I do that, the square undoes the square root, and that leaves me with 5x minus 1. Over here, I have a binomial being squared, so that means I have 2 plus the square root of 3x minus 5 times 2 plus the square root of 3x minus 5. It's a binomial being multiplied by a binomial. So we're going to do it the same exact way that we did on example 5 and on example 4. So 2 times 2 is 4. 2 times the square root of 3x minus 5 is 2 square root of 3x minus 5. The square root of 3x minus 5 times 2 is 2 times the square root of 3x minus 5. And then the square root of 3x minus 5 times the square root of 3x minus 5 is the square root of 3x minus 5 squared. So let's break this down and see what we have. On the left side, I do not have any like terms, so I'm going to go ahead and bring those down. On the right side, I'm going to go ahead and bring down 4, and then let's see. 2 times the square root of 3x minus 5 plus 2 times the square root of 3x minus 5 is 4 square root of 3x minus 5. And then the square root of 3x minus 5 squared is just 3x minus 5 because the square undoes the square root. So let's go ahead and clean this up a little bit. So we'll have 5x minus 1 equals 4 minus 5 is negative 1 plus 3x. And then 4 square root of 3x minus 5 does not have a like term. Well, now I have another radical, right? So I need to isolate this one. To do that, I'm going to move everything else over to the other side. So I am going to add 1 to both sides, and I'm going to subtract 3x to both sides. When I do that, I get 2x is equal to 4 square root of 3x minus 5. Again, I still want to isolate the square root of 3x minus 5, so my next step is going to be to divide both sides by 4. So this is going to give me x over 2 equals the square root of 3x minus 5. Now my square root is isolated, so I can do that process all over again. So to undo the square root, I should say, we are going to square both sides. Over here, I'm using that quotient rule. So you may recall, if I write it up here, if you have a quotient raised to a power, again, that power goes to both parts of your quotient. So x raised to the second power, let me write this over here, is x squared, and 2 raised to the second power is 4. The square undoes the square root, and that leaves me with 3x minus 5. From here, I want to go ahead and get rid of this fraction, so I am going to undo division, and I am going to multiply both sides by 4. So I'll be left with x squared equals 12x minus 20. I'm going to go ahead and get everything on the same side, so I'm going to subtract 12x and add 20, and that will give me x squared minus 12x plus 20 is equal to 0. Well, I can factor this, right? It will factor into x minus 2 and x minus 10, because negative 2 times negative 10 is positive 20, and negative 2 plus negative 10 is negative 12. Well, from this part, I can use the principle of zero products and say x minus 2 equals 0 or x minus 10 equals 0. If I solve this first equation, I'll add 2 to both sides and get x equals 2. If I solve the second equation, I'll add 10 to both sides and get x equals 10. So let's go ahead and check both of these solutions. So for x equals 2, we will have the square root of 5 times 2 minus 1 equals 2 plus the square root of 3 times 2 minus 5. 5 times 2 is 10. 10 minus 1 is 9. 3 times 2 is 6. Minus 5 is 1. The principal square root of 9 is 3. The principal square root of 1 is 1. 2 plus 1 is 3. 3 equals 3, so 2 is a solution. Now let's check x equals 10. So we'll have the square root of 5 times 10 minus 1 is equal to 2 plus the square root of 3 times 10 minus 5. 5 times 10 is 50. 50 minus 1 is 49. 3 times 10 is 30 minus 5 is 25. The principal square root of 49 is 7. And the principal square root of 25 is 5. 2 plus 5 is 7. 7 equals 7, so 10 is also a solution.